Okay, it looks like we're live. Though we don't appear to have any desktop audio. Let's see if we can get that to work. Well, I got the sound to go away completely from me. Alright. Yeah, that should be good. Alright. Test. Test. Okay, seems to be working pretty well. And well, now you've got music, but I don't have music. Okay. Well, hopefully that's working well. Let's get over to working on the matrix board case design. Alright, so we'll start on the top, and we'll go for a sketch, and we'll call this board outline. And we'll put that on the top plane. Ah, hello Road Rally Race. Yeah, so let me just give you a quick peek of the PCB we're designing a case for. I have it imported into OnShape, and it's, well, this would probably work, but I'm not sure it's my final revision. Let's get this guy. Uh-oh. That looks... okay. We were getting a little suspicious here. Let's add a mate connector. And we'll stick it on that hole. And we'll add another mate connector. Well, I'll stick it there and then move it. Close enough. Alright, now we'll just do a simple fastened mate between those points. Ha. Well, good thing we did this. I think my positioning on these may have drifted a bit. I used a automatic feature to do the via stitching. Which, of course, I have to remove because I switched this to a 4-layer design. Using a ground and a 5-volt plane instead of these big fat lines across the surface. So let's fix the board. I'm actually using Easy EDA. Okay, so I have KiCad on here too. Or KiCad. I just don't use it. It's I found Easy EDA easier. I just also have more experience with it. That's what I designed these boards in a while back. Let's grab the reference guide. So oh god, it's loading a million applets. Yeah, there's a different document that I'm looking for. Oh yeah, there's a ton of stuff, but I'm using pin headers instead of the footprint for the device, so. These are reference designs to use with Shahaz, not the sad board. Yeah, I think this is the one I'm looking for. There's a PDF in one of these that has like the footprint I need. This one. Ah. I'm dumb. I used the PCB LAN pattern. I need to use this. This will only be slightly annoying. These can go anyways, since I'm considerably changing the power design. And they're grouped. Alright, 56 plus 1.5.25 gets me that. that fixes that. Let's... Yeah, so... This is the ground plane. It's a whole copper pour layer just for ground that I'm switching to using. And the 5-volt plane. Much better than just using a bunch of fat traces. I'm sure there's an unroute all somewhere. And these are getting repurposed to not be I2C lines. Yeah, I'm gonna rewrite that. I decided to go to a power plane design today after completing the board design last night with the trace design and just going, I don't really like it. Why do I have it? And auto route's like, yeah, I'm just gonna add some secondary traces for you. Why is that not connected? Reasons. Yeah, that's better. That definitely... Yeah, auto route put some nonsense in here. What? No. That's gotta get moved over. My pull-ups for the SDA and SCL lines became an absolute nightmare in there. Oh yeah, I definitely have to do some pointless PCB art on it. So, the device is 4 circles when you're looking down from above. I could probably grab it. So, when you see this from above, you're going to be able to see down onto the circuit board. So, it has to look cool. And I can get a free coupon for multicolored PCB surface coating, so why not put, like, I don't know, I'm thinking a picture of a black hole and then like Saturn and like other cool planets under each one. Never trust the auto router. Okay. Pretty much undoing my design now. All right. Because I desperately... You are right. I do need a hot cup of something. I have like 3 drops of plain milk left in this mug. But let's get the DC barrel jack I want on this. All right. These are my options. Trying to determine whether I want to go with a 2 mil center pin or a 2.5 mil center pin. And then, yeah, I want surface mount. What do we got in here that looks really good? All right. 2.5 inner. We got a few options. Let's check out the data sheet with this one. No, the options are 2 and 2.5, and a lot of my stuff looks like it's 2.5. I can measure this, but what do we got here? That is 2. But it could be 2.5. It's just ridiculously hard to use these to measure this tiny little hole. Worst case, I'll just buy more power adapters. Because this is a 2.5 by 6.5. Wonder if I can find an adapter for that. Because the problem is, all my stuff is either 5. Yeah, this is 5.5. So I need 5 point. But will a 6.5 mil jack take it? No. 6.5 is for... That explains it. It's a laptop plug. That's why it's surface mount. All right. Screw it, we're going USB-C. Just gonna put a second USB-C port on the device. Much easier to get a USB-C plug. Alright, let's place a common... Oh, that looks good. Yeah, this one's just going to be USB-C power. So I can get the 4-pin one and just wire it up to an IC, I think. Well, normally it would be powered over the MCU, but I want to be able to put an extra power into each unit separately so that you can power a ton of these in a chain. Why make something if it's not epic, right? Now I'm getting to the weird ones. Hey. I could just get... Oh, there we go. Type C 6P. Half the price of the one I don't need. Okay, now... I have a power design on this other screen for it that I'm working on. Want to get the data sheet going on for that. Alright, let's take a look at this data sheet and see if this is suitable for power use. Hello YouTube! Bob, Living Dead, great to see you both. Yep, we're doing some circuit board and case design today. So, yeah. Well, that's upside down. Let's see if there's any power spec on this or anything. Uh, 3 amps max. 5 volt. Does that mean I can use it for PD if I put the right chip on with it? As the idea is to use a USB-C to power mux, and then have that be able to power, I guess, the Xiao on board via its 5 volt pin or the lights and other things. Okay. I think there's something wrong with my audio card, because sometimes it explodes like that. I'm just replying to an invitation from Seed, one of the project managers, about a user group for contributing to them. Cool. That's awesome. Now, where did OBS go? How much power do the lights take? So each of these modules can take 700 milliamps. Each of the sub LEDs can take up to 15, and then like each color inside it is 5 milliamps. They're really quite efficient. But that's only 700 milliamps if you run them at full white on all LEDs. So I have them tuned to take under 1 amp just based on keeping the brightness low. And when I say low, well, let me plug them in. So yeah, it just looks white right now because they're just so bright. Maybe this one can see them better. Come on, get a good view on it. Yeah. Well, these I don't like running at full power for a long time because they get like hot enough to burn your fingers. But they're also made on a 1 millimeter thick, ultra thin board. So, yeah. The display right now is sound reactive. There's a microphone on here, and it's picking up the beat from around us. There's some full bright coming out of it, but only on a few of the columns on purpose, because this is just a test mode. Alright, so we're placing a USB-C connector. Let's point it like this. Oh, this looks good visually to me. I have two other styles of diffuser. because these are meant to display readable text. But the diffuser... Still too bright. Wonder if I change the room a bit. No. No, there's just no hope. Oh, that one took its board right with it. Let's just unplug it for a sec while I do surgery. And then we'll get this guy on it. That actually reminds me of an interaction I had on Reddit. I shipped 6 of these to someone, I believe, in Romania, or... and they were using them to make indicators for a race sim. So that's why that reminded me of it. But the idea behind these is actually to be an eye-catching display. Boop, 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 boop. This is also an audio reactive one, but it's not a very good one. I should have spent a little more time on it. I'm trying to use it as a clock. All right. Okay, where is my documentation on what I'm trying to do here? I have a billion tabs open, and yeah. All right, YouTube chat. Only looking for 5 volt. I'm gonna bring in 12 or 5 volt and then step it down to provide a bunch of amperage to the lights. So I need a couple of things. Yeah. My AI was yelling at me to go stream. It actually helped. I eventually listened to it. Let's see, is a 6-pin connector okay for the application we're doing here? It seems to be... Nah, too bright. I know. What if I stick it way the heck over there? And give it power. It's microscopic, but oh well. Oh, moving it again. Spending more time playing with my toys than actually doing work. I guess since it's running on a battery, I can just put it anywhere. Yeah. Let's see. So I have the project in it here for it somewhere. Moved it into the lead subfolder. So I actually have a font for it, or apparently a partial font for it. Yep, there it is. sit still. I think I need to put a weight in the bottom of the case when I actually build the final version. All right. All right, so yeah, a 6-pin should work. I'm just going to close about 50 tabs on this browser over here. I have to figure out which USB-C so I need a PD trigger IC, a buck converter, and a power mux. Okie dokie. That's expensive. Well, let's look at the data sheet for I2C USB power sync controller. Okay. I think I have to actually talk to this one. I think I need to get a dumber one. I'm going to see if we can find a less smart power delivery IC. Well, let's just get rid of the model number. I've got nothing under the search right now. What about USB hub controllers? No. Am I in the right section? What section is this even going to be in? Well, let's search for PD. Oh, okay. I actually got some hits this time. What is this tiny thing? 100-watt power receiver controller. Okay. Okay, that's starting to make more sense. Although it appears to be written in Chinese. Alright, but let's find something cheap. Quick charge 2. What else are we gonna find? Power Ethernet, power supply controllers and monitors. Alright. USB charging IC. One. $11. No. Alright, well, I know the name of one of them, so let's find the category it lives in. It's made by the company Diodes, and Diodes Incorporated. And Power Management Specialized is the category that got under. So let's go back and see if we can get into Power Management Specialized. Here we go. don't think I'm asking it for the right thing. Where's the connector type? Alright, let's see. What does TI have in stock for this? I don't know. I'm not sure what 5.K resistors do in a USB header currently. I know they set some sort of mode. Okay. Oh, these are USB charge output. I need a USB sync. Okay, so here's the diodes ink. Okay, the C is the dumb one. Alright, yeah, I like this one. Even though it's probably like $5, screw it. And of course, the part isn't actually available? What? I swear it just was. Yeah. That appears to be it. But it's not available as a footprint. And my speakers just keep getting bad data from the sound card for some reason. Back to looking for a USB-C PD sync. Let's look at just the diodes company product. And hey, this one's on sale. What does this do? Constant voltage. No. Yeah. I do want to kind of design my own speakers, but I also don't want to get distracted. Because I'm super easily distracted. Alright, in stock. That should help. Power receiver controller, maybe. Alright. I gotta hit the bathroom. I will be right back after a few minutes. I have decided that we're just going to go with like a buck converter and some resistors, because this is nonsense. Alright, let's try and see if that exists. Well, it's in stock, there's a ton of it, and it's relatively cheap. So let's take a look at the data sheet on this. PD physical layer IC for Type-C input. Oh, yes please. Typical application schematic. Hey! So it needs a few ICs to go with it, but that shouldn't be too hard to throw on there. And what's the so we can just do 5 volt 3 amp. That is more than enough for each board. Is that connector rated for 3 amps? I don't want to melt anything, so let's check the data sheet. Open yet another tab. Yeah, I think this one tops out at 3 amps is what we saw. Yeah, pin 3. Okay, what is pin 3? I don't know. Rated for 3,000 cycles. Doesn't seem like a lot. Oh yeah, current rating 3 amps. Is there a filter for rated insurance? Ah, hey. Yeah. Ah, they don't stock it. Well, what about this one? Hey, the whole thing's in English this time. That's helpful. I think that's copyrighted music. Guess I hit skip one too many times on the music, but yep. Back to the start. Just to have some sound in the background. Alright. And this one's also rated for 3,000 cycles. Or it's the one I was just looking at. Well, let's try sorting by price. Maybe the more expensive one. How about this? Yeah, there we go, 10,000 cycles. Very nice. And of course, there's no drawing for it. Oh, that one has a drawing, stock, and is the right thing. Alright. We have successfully updated to a less janky Type-C connector. Now let's get the reference drawing up. swear we have a charging IC around here somewhere. I think it's this one. Yeah. So yeah, I think we need a few ICs for this. Hey, would you look at that? I think it's exactly what we need. Yep. Big shout out to Open Source Hardware Lab. I'm just going to use this design, which I can't paste in here because I'm not logged into my own session. Yay! Okay, yeah. That's super helpful. Oh, now I have to actually reach over. Ah, yes. Bots. Always a part of Twitch. An apple has escaped. Alright. Close that. So, we no longer need that. Come back, Easy EDA. Uh, 2 by 5.1K. Yeah, that sounds about right. We'll go import, Easy EDA standard. And there's that board. And we're going to import that into this existing project. Well, there's a board. Where's the PCB for the board? Schematic. Where did you go? Maybe I only exported the board? Oh, time to reopen some tabs. I think that's what happened. Think that worked. I need to attach this to one of them. Set as existing board, and it goes to that guy. Alright, I want the USB-C connector. Get rid of that. Oh, I'm sure you're quite brilliant, and I appreciate you being here. Yep, there's your 5.1Ks. And again, too many tabs open. There we go. Alright, you can go down here for now. Let's get this tidied up a bit. Where's R3? I think we lost R3 in translation. It's R6 now. If we go look over here, yeah, R3. Cell D in. Okay, so let's check the data sheet and see what that configuration is. Dox myself a bit. Yeah, currently set up to auto-negotiate max voltage. We don't want max voltage. We want 5 volt 3 amps, so we have to change the resistors up a bit. Oh, derp. We just don't put the resistor in and drive it to ground instead. If we float it, we get 15 volts. I had like 10 calculators open. Well, that's what happens when you put a calculator button on my keyboard. Alright, so we simply need to change this. I'm going to use a wire just to be silly. But, boop, boop. Now, why is it unhappy about driving that to ground? I just don't know. Well, maybe that's what the short flag is for. Yeah, I know, gross, eh? Let's flip that whole thing over. And put a 0 ohm resistor there instead. So you can put whatever else you'll want in later. Nah. We're just gonna put a 0 ohm resistor in because it's easier to trace. No, it's not. That's dumb. It's a little better. Stuff was a bit off-grid there. Right. I edited the wrong block. Whoops. I do want to learn best practices, though, so thank you for mentioning that. I am learning circuit board design as I go. I don't see the ICs on the board. Save. Oh, some of my stuff is missing footprints. Okay. So we'll just grab this guy, hit the device. Alright, now we should actually have a footprint for that device. And we have to do that for each device to be able to apply them to the board. Yeah. This is all hobby and learning at this point for me, so they don't have to be professional quality. So I gotta read up on what makes a professional quality board. Because if I'm gonna make something, I want to make something good. That's why we're throwing this USB PD on here, because I didn't want to settle for a shitty barrel jack. Okay. Yeah, it's the same part, so it should be replaced already. Cool. Save that. What else do we have? Well, probably this. Ah, now I wish I hadn't deleted the one I placed earlier. This should just be the stuff I've used recently, hopefully. Or everything I've ever used. We've got an NRF54L chip in there. Raw RP2040s. I need just search for 6P. Yeah. Alright, let's check the browser tabs, because I cannot even remember what that one was. This one looks like it has a rubber seal. I don't think I need that. Honestly, that's pretty rad. Yeah, why not? Let's see if we can get this into the design. Why do I have just the word Hanksia in my clipboard? copy the right thing this time. Oh, that's mildly annoying, but... that. Move the whole mess up a bit. Okay. So now I have a USB connector that exists. Let's save and try to convert the schematic again. All right. Okay. Seat number. I think it's upset about the numbering. no label for you. Okay, I think that should be good, other than fixing a few more devices. I'm sure I could have imported this properly, but that would be too easy. Oh no, all my stuff has come disconnected. Okay. Let's break my resistors. Or at least lose the names on them. And there we go. And we'll do a bulk replace to get 2 resistors at the same time. Anything else in the list of missing a footprint? No. Alright, now we're good. Of course, we have no resistor names, but... let's see if we can just cheat on that. Hey, if I cut and paste it. It gets a proper name again. Instead of me manually typing something that may be wrong. Okay, that's looking better. Alright, stop fidgeting, save, and let's see if we can get parts on our schematic. Alright. Real-time clock can take a hike. Let's take a look at how it got laid out on here. Okay, just all in a big block to ground. Except for this guy. Oh. An auto parts placer. Maybe. I don't know. Okay, so yeah, those are just pretty much decorative. Alright, where are we putting this? Move the whole component. Trying to move you. All right. Okay. I guess I want this as close as possible to the USB port. So the end's on this side, so it makes sense to point it that way. let's make sure these are on the same layer for sanity's sake. Make sure I'm putting this all on the correct layer first. These all need to be on the bottom. Apparently I have things selected that can't be layer swapped, so we'll just go one at a time. What is this net? I guess I gotta throw some NC flags on here or something. No, it's Q1 pin 1. Let's see. I think it's V-Bus G, but I'm not sure. Was that V-Bus G? I don't know. Yep, VBUSG. to one pin of this, and V bus G goes to that pin. And then there's our 5-volt out. Okay, CC1 and CC2 need to be driven to ground and connected to this. So that's what these guys are for. Boop. Boop. And make sure we're editing bottom layer. Yep. You can hide under the device. The goofy music really does feel like it suits this particular scene. I guess I'll put these guys on the signal layer. Okay. Back to editing the bottom layer. Is this supposed to be a 1206? Kind of huge. Well, probably needs to be. Does that make sense with the datasheet? Okay. I'll just redraw that so it's tidy. Let's just go a little fatter on these power wires. A little too fat. Okay. Okay, I don't want this one. There we go, and we'll change that to the out plane. And we'll slap a via through it. let's just go crazy with the vias on the VO. I don't know if you can do that, but I'll find out. Use a consistent trace width. I don't know what that carries, so it can be fat. Fat and short, that's a way to go through life if you're a current trace, but otherwise seems not so great. Okay, so swap the battery over to this side. And let's put the clock chip over here. I should be changing that on the schematic. Alright, where's my clock chip? Everything that's VCC needs to be... Three V3. And I will return shortly. All right. Got all that switched over. All right, 3v3, and then now I still need to short 5e to ground. All right. I think I'm done streaming for tonight. I did just spend a bunch of time tucking my kids in and stuff. Thanks to everybody who came today. I'm gonna pop a Twitch stream and stop the YouTube live. But I hope to see you all again next time. Alright, the Twitch raid is selected with all 2 of my amazing viewers. Thank you for being here anyways. It was kind of a boring stream. I gotta get better music going on. Alright, we're raiding it and dropping the video.